What's going on, everybody? Welcome back to Deep Coding. In this session, we're going to talk about remove all adjacent duplicates in a string. We solved a very similar question. I put it in the description below that we were using a stack to solve the problem. Uh, in this session, we provide two solutions. One is using a stack, the other one using two pointers. Let's start with the two stack. As we talked in the previous video, as you can watch in the description, we can use a stack and we can do a iteration over each character of my string and add it to my stack. For example, in this example, A, B, B, A, C, A. So first A goes in. Next, before I put B, push B into my stack, I check if it's same as A or not. If it's not, then I just push it in. Otherwise, same as the second B coming in, if the second B wants to come into my stack, the top of my stack is already B, which is same as, which is a duplicate. So instead of pushing the second B inside it, I just pop out this B. Then next element coming in would be A. So top of my stack is right now A. So instead of adding A, the second A into my stack, I just remove my A. So I go to the next element, C. So C right now, the stack is empty. So just simply push it in. Next would be A. So if A wants to come in, is not equal to top of my stack, so I can just push it in. And then I start taking the elements out one by one, and then I would receive AC because it goes from top of this stack. Then I reverse it, then I get CA. And that would be the result. That's the first solution. Let's write a code for this solution, and then we go to the second solution, which is optimized in terms of space consumption. Let's write the solution together. So we need to have a stack of characters at the beginning. Then I iterate over each element in my string. And if the stack is empty or the top of my stack is not equal this character that I'm checking, then I can simply just push this element C into my stack. Otherwise, which means that the top of this stack is same as the character coming in, I need to pop the element out of the stack. So after this for loop is done, we're basically done with the iteration and we just need to pop the elements out of the stack. So I create a string, an empty string, res, and while my stack is not empty, I add this res. I add the top of my stack to this res and also stack.pop. At the end, so right now the result that I have is reverse. So I need to reverse it again to get the correct order. So I reverse my result, begin and result at end. And at the end, return my result. Let's run it together. Empty. Oh, I have a typo here. Empty. Okay, that's correct. Let's submit the code. Yes, accepted. So that's the first solution. As you realize, we're using a stack. The space that we're consuming, in worst case, it would be O of n, big O notation of n, where n is the maximum size of the string s. And in terms of time complexity, would be big O notation of n because I'm iterating through every character of s and add it to the stack or pop it out. Same thing, I'm iterating through the size of the stack here. So time complexity is O(n), space complexity is O(n). But we can modify or optimize this solution by providing another solution by replacing a stack with two. In the second solution, we need to define two pointers, one current and the other one end. Let me show you how we can do that. Let's continue with the same example. A, B, B, A, C, A. At the beginning, I have my end cursor and current cursor defined at the beginning. So if it's the beginning, every time I need to compare my current element, my current pointer, the character that C is pointing to with E minus 1. So at the beginning, because we don't have E minus 1, all I need to do is to copy C into E and move E1 to the right, C1 to the right. So in this case, because A is here, I just need to copy C to A, but doesn't make a huge difference here. So as C moves to the right and E moves to the right. Now, I just need to compare again C with E minus 1. So C is pointing to B and E minus 1 is pointing to A. They're not duplicates. So what I need to do is, again, copy C into E, which is again the same thing, and move both to the right. Now, in this case, C is pointing to B and E minus 1 is pointing to B. So it is duplicate. In this case, instead of copying and moving both to the right, all I need to do is move E1 to the back and move C1 to the right. So I would end up with this C pointing to A and E pointing to B. In this case, again, I need to continue doing the same algorithm. I compare the character that C is pointing to A with E minus 1, A. So they are equal. Again, what I need to do is I need to move E1 to the back and C1 to the right. Now, because E is the 0 and I would like to compare C with E minus 1, I can't do that. So I need to do it in the other else statement, which is copy C into E, which would be C, B, B, A, C, A, and move E to the right, C to the right. So I've already copied C into A, and now my E would end up being here, and C would be end up being here. Now I need to compare C and E minus 1. So E minus 1 is pointing to C here. So A and C, they are not equal. What I need to do, again, move a copy C into E. So I would end up with CA and move both pointers to the right. So my C would end up here and B end up here. So that would be my E, that would be my C. So at the end, all I need to do is to get a substring from 0 to up to E. So the answer would be CA, and that would be the same answer we have here. Let's write it, implement it and write the code together to make it more clear. Again, I need to make a pointer, that something index that points to the end of the character, end of the string. Let's call it E, and I start from 0. Then I would write a current element, a for loop with current element starting from 0, going all the way to s size and current plus plus. And I would write whatever I just say. So if E is bigger than 0 and the character at current element is equal to the character at E minus 1, all I need to do is we find a duplicate. So I just need to say E minus minus. I just need to move my end pointer one to the back. Otherwise, what I need to do is I need to copy SE, S current. So I need to just copy my current element into my end element and increase n. That would help us to generate what I just talked before. And at the end, I need to just say substr, get a substring from 0 to this end element. Because in C++, the end element would never be considered into my substring. It would be from exactly 0 and upper bound, not exclusive E here. So it would be just C and A. So if I do that, should be the correct answer. Let's run it together. Okay, both cases are passing. Let's submit. Submit. Okay, this is a more optimized solution in terms of space complexity because I'm not using a stack anymore. I'm just using constant space. So as I'm moving on, my time complexity would be big O notation of n, but my space complexity would be O of 1, constant space. I'm not saving anything into memory. I hope you like this video. If you have any question, please write down in the comment section below. And don't forget to subscribe the channel. It would help me a lot.